Okay, we're here in Bradford today and we're looking at this sculpture called the Bradford Imbalance Sculpture, which is outside the university. And it's made of two semi spheres, 2/8 of a sphere, connected together at the centre. And we've got a 4.5 metre tall or diameter sculpture, which is made of steel and bronze, so it's going to be fairly heavy. And because it looks a little bit unstable, it's also going to be a bit of a challenge to analyse. The secret to our sculpture remaining standing is all to do with centre of mass. And to illustrate this concept, we've got a system with a wine glass, a cocktail stick, and a composite object made up of two interlinked forks. The centre of mass is the perfect balance moment of an object, whereby any axis is not going to rotate or overturn. This is basically when all the moments of the mass equal each other around whichever axis we take. And we're going to look at the centre of mass of this two-fork system. We're going to demonstrate it by seeing if we can balance it on the wine glass. There you have it. The forks are balanced on this pivot just at the top where the cocktail stick meets the wine glass, and it looks barely believable. The reason for it is because the centre of mass of that composite object of those two forks is somewhere in a vertical line below that pivot point. And this is because the moments of mass of this fork are counteracted by the moments of mass of this fork somewhere along this axis of symmetry between the two forks. Actually, this system is fairly stable, because if we want to rotate it a little bit, as long as this pivot doesn't move, it will come back and rest at the same position. What we've talked about is that centre of mass is the point on an object where all the moments around each axis balance each other. So the moments of area are completely equal. And we can illustrate this using this example. We've got an irregular shaped piece of paper and we've pinned it onto a pinboard so it can actually move. And what it's doing here is the moments around this vertical axis, because of gravity, are equilibrating. So this line down here, which you can't see at the moment, but we're going to illustrate, has equal moments of area on either side. And it's worth noting here that area is equivalent to mass because this piece of paper is uniform all the way. But even if it wasn't, then the moments of mass would also be the same. What we can do is we've got a makeshift spirit level, and if we hang that on top of this axis, you can see it gives us the vertical. So I'm going to draw a line which follows as near as possible the line indicated by this level. I've drawn a line which should go through the centre of mass somewhere. But to find it, I'm going to need at least one more line like this, and they should intersect. I'm actually going to do it with three, and hopefully they'll all meet at the same point. Let's shift this round and do it on a different point. Okay, we've rotated this to a different angle, and it's found its centre of mass somewhere along this vertical line. But we'll find it again with our little spirit level tool. And then this, where these two axes intersect, just make sure it's free to rotate and we'll find its way back to the centre. This point here should be the centre of mass of this piece of paper. Try and draw it in again as accurately as possible. So we found it. Now the last thing to do is test it. Okay, so we've got our last orientation, and if all's well and good, the vertical line is going to go straight through here. Hopefully it does. First, let's just make sure it's free to rotate and find that equilibrium point. It seems to be fairly good. Hopefully it's not catching on the pinboard anywhere. Seems fine. And now we'll hang this on top. Ooh. There we go. Obviously because of the friction of the pinboard it does stop it, but once it's free to rotate, you should see that any axis, so long as it's not a parallel axis, should give you, any two axes should give you that center right in the middle, which is the center of mass.
So if I put my finger on the center of mass, the paper balances perfectly, but anywhere else, and goes away.